Today, we will explain the Panasonic 1.5-ton outdoor PCB to you. We will also describe which components are more likely to fail and explain their functions in detail. The first piece of information about the PCB is this. The rectifiers and IGBTs on it cannot be separated from the heatsink by simply desoldering because there are no holes at their location. The IPM, Intelligent Power Module, is tightly fixed in place, and the PCB has proper holes designed specifically for the IPM. However, there are no such holes for the rectifiers and IGBTs. Instead, thick tracks, bulk prints, pass through these points. Therefore, to check these components, you will first need to desolder them and then remove the screws to detach and inspect them properly. When we examine this PCB, the first thing we notice is that there are 3 rectifiers installed, 1 here and 2 over here. The design of this PCB is structured in such a way that the 2 rectifiers are specifically used for PAM technology to work with the IPM. Meanwhile, the SMPS, switched mode power supply, powers and runs the entire system. It generates 12 volts and various other voltages, which are supplied through this rectification process. Now, as you can see, just like there are 3 rectifiers in this PCB, there are also 3 fuses, each serving a specific purpose. Let me explain their functions. The first fuse, which is connected to this connector, is a 20-ampere fuse. It controls the entire system. Next, there are 2 additional fuses. One of these is dedicated to controlling the SMPS. If there is a short circuit in the SMPS, this fuse will blow to protect the system. The other fuse is specifically for the DC fan motor. If there is an issue or a fault in the DC fan motor, this fuse will blow to safeguard the motor and the circuit. If we analyze the system from the beginning, you can see that zener diodes have been used extensively in the circuit. These zener diodes play a critical role in protecting the system. In case of a heavy spike or a short circuit, the zener diodes will blow, and the corresponding fuse will also blow. As a result, the SMPS will shut down, causing the entire system to stop functioning. After this, there are 2 filters to control spikes. Then, a line filter is placed to further minimize spikes. Beyond that, additional filtering is implemented to reduce spikes even more. Following these filters, there are 2 capacitors installed, which are connected to the earthing system. Let me explain further. These capacitors are connected to the circuit in such a way that their prints lead to the earthing. These capacitors are specifically designed to control surge voltages, ensuring the system remains stable and protected from voltage fluctuations. Now, as you can see, 3 switching relays have been used in this PCB. The reason for this is that it's a larger outdoor unit, which requires 3 relays to handle the load effectively. Additionally, 2 PTC sensors have been installed. Now, I will explain what has been done. Keep in mind that when working with a Panasonic unit, it employs various systems that you need to be aware of. Previously, I made a video explaining that the 1.5-ton unit won't turn on at all if the communication wire isn't connected between the indoor and outdoor units. Without communication, the unit will not function. However, the system in this unit is slightly different. While some aspects are similar, there are noticeable differences. Let me explain. In this system, 3 relays and 2 PTC sensors are used. When you supply power to the system without connecting the indoor PCB, only one of the 3 relays turns on, while the other 2 remain off. This is for safety purposes, ensuring the rectification circuit and IGBTs stay protected. Once the indoor unit is connected and communication is established, the system starts functioning properly. Additionally, when you turn off the unit using the remote, the system completely powers down, turning off the 2 relays. However, 1 relay remains on. The purpose of this is to protect the system in case of an electrical spike. By keeping the main components isolated, the rest of the system remains safe from damage due to sudden voltage spikes. Right now, you can see that many wires are passing over the PCB. If we don't understand these wires, we won't be able to figure out how the system is functioning. Therefore, it is crucial to understand each wire's role. I will explain the function of each wire in detail shortly, but before that, let me tell you that 3 filtering capacitors are installed on this PCB. These components are essential to further filter the DC voltages and ensure stable and smooth operation. These 2 wires are connected to the reactor. Normally, companies pass DC voltages through the reactor to improve the power factor correction, PFC, before feeding them back into the system. However, in this Panasonic PCB, the company has designed the system differently. Here, the 230 volts AC is passed through the reactor first and then fed into the system. Let me explain how this happens. When the 2 switching relays are turned on, the current flows through the PTC sensors. After that, the 230 volt AC reaches this wire and then passes through the reactor. After passing through the reactor, the electricity comes out from another wire, which I'll show you below. When the electricity enters at this entry point, it passes through the relays and PTC sensors. From here, it flows through the reactor and reaches this point. At this point, the phase is present, and it is then then fed into the rectifier. Now observe here, this is the rectifier, and here is another rectifier. This is how the system ensures proper voltage rectification and functionality. Now, let me explain another important logic in this system. You'll notice that the neutral wire directly goes to one of the rectifiers, but it does not go directly to the other rectifier. Let me clarify why this happens. There are 2 points here, and they are connected to a CT, current transformer. We've already made a detailed video on CT. If you haven't watched it yet, make sure to check it out. This CT monitors the current flow. After passing through the CT, the circuit completes at this point. Once the circuit is complete, the system converts the electricity into 220-230 volts DC. At this point, we only get DC voltage, typically around 230 volts, 240 volts, or sometimes 210 volts, depending on the system's design and conditions. The negative point of this rectified voltage is routed to a capacitor, and the positive point is also connected to a capacitor. Let me explain how. There are 2 wires attached here. One represents the negative point, and we will first focus on discussing all the negative points in this system before moving on to the positives. Now, let me explain. The wiring consists of yellow and white wires. The white wire goes to the DC fan motor, while the yellow wire connects to the 3 capacitors, where all their terminals are interconnected in series. From there, the yellow wire continues to a brown wire, which leads to another point in the system. This point connects directly to the negative terminal of the IPM, Intelligent Power Module. Moving to the positive side, the positive output of the rectification is connected to a red wire, which goes directly to the positive terminal of the filtering capacitors. Here, the voltages are filtered out from any kind of spikes or fluctuations, which is then carried by a black wire to the positive terminal of the IPM, completing the positive circuit. However, there is one remaining wire, and it appears that the negative side is not yet fully connected. Let me clarify. This is the blue wire, which originates from the DC filtering capacitor. After the rectification process converts AC to DC, the positive side goes to the filtering capacitors, while the blue wire connects to a switching relay. When this relay turns on, it completes the rectifier's system circuit. As the circuit completes, the voltage increases and is directed to the IPM, enabling the system to operate. Once the circuit is fully functional, the compressor and other components turn on, and the system begins to work efficiently. Click on the left or right thumbnail to watch our next videos, and subscribe. Thank you.